this one is starting from somewhere in the positive direction, or keep walking towards the right side, which is positive as well. So for the second line, this one is more like starting from, maybe starting from this point. Okay, I start from this point, somewhere on the left side of the reference point. So it is negative. But I walk with a constant velocity to the right. Okay, I walk constantly to the right. So I'm gonna pass some point equal to 0, which indicates pass through the reference point. But I didn't change my velocity, I just keep walking. So I have something like this. Or even the third line. This one is maybe this time I start even further on the left side. So that's more negative, but I go constantly to the right until stop somewhere near the reference point. It just indicates where, like the different locations where I start, but the velocity doesn't change because they all have the same slope. The VT is like somewhere like this, okay, because we don't have any like numbers to calculate. So let's just do that. And further, it indicates the AT is 0, right? Because horizontal, like velocity is constant. Okay. Okay, so let me put this one thicker. There we go. So let's keep going. Okay, let's keep going the next one. So for this one, first of all, straight means constant slope, so constant velocity. But could you just think about what should be the VT look like? This one is positive slope, but this one is negative slope. So the velocity is below 0. Yeah, so the velocity is going to be negative. So I should have my curve somewhere over here. So this one is going to be something like, let's say the first one, okay, the solid one. This one is like starting from somewhere here. Okay, this time I start from somewhere here, and then I walk towards left. Okay, so this time I walk towards left. So I still walk with a constant velocity, but the thing is I'm walking towards left, so the direction is left. So the direction or the numerical value is negative. So negative doesn't mean you walk slower. It just means the direction, okay, it's negative. So in other words, if I give you negative 4 meters per second and positive 3 meters per second, negative 4 meters per second is faster than 3 meters per second. It's the same thing, it's 0. So far we have been dealing with constant velocity. So you can see the first 3 PT are all straight, end up with 0 AT. But for now, we're gonna do some advanced PT graphs. They have changing slope, which means their velocity is changing. So we have to generate some VT graph, looks like this, that, or that. So let's see the number 4, the middle one. First of all, I realize no matter which one, the slope is positively increasing. So we did 2 examples, right, already for this case. So I can just start, or assuming the initial velocity is 0 meters per second, and then go straight up and then increase. So I'm going to have something like this. So same thing. If I want to describe the type of motion, let's say, let me describe this one, the middle one. So I am starting my journey from somewhere on the left of the reference point. So I start from here and speeding up, walking towards right. Okay, I start from somewhere, the point on the left relative to the reference point, and then speed up, walking towards right. So that could be the PT of the middle curve. Think about how should I do the AT for this case? Okay, anyway, let me just draw that since we already did it twice. I'm gonna give you a little time to try the rest of 3. So this one gonna be positive. You just draw something right here. So this one has positive slope. So we have a positive acceleration. Let's look at this one. Okay, I'm gonna show you one more and you can try the rest of 2. Slope. I have slope being negative this time. Oh, sorry, it's still positive. How come I say negative? Still positive, sorry. Yeah, still positive. This one is still positive. So slope positive, but decreasing. So slope, or let me put positive slope decreases. So what does that mean? Slowing down, right? This one means slowing down. It also means positively slowing down. So how do I illustrate VT to have positively slowing down? So it's not going to be look like that, since this one is positively speeding up. So I should have something looks like starting from positive but fast and then slow down. So a very common mistake or a very common misunderstanding, it's when you have a VT like this, even though we are decreasing, but we are still walking towards positive direction. Because it is still positive, your velocity is still positive. It's just you walking slower. So AT is going to be somewhere below 0, because this time if you do V final minus V initial divided by T, you can clearly see the V, like somewhere the V final, okay, is 0, and a V initial, it's something positive. So you will end up with something negative, but constant. Our diagram will be a straight line, but negative. And I'm gonna give you 3 minutes. Think about the last 2 cases. Do you guys have any idea?
Decreasing.
Increasing?
I think it's decreasing.
Yeah, it's like starting from like -10, like a lot of a very steep, and then become to 0. But if you think about velocity, so you can take it as at the beginning, we are negatively moving at -10 meters per second. But once you keep walking or once you keep moving, your velocity becoming to -5, -4, -3, 0. So like I said before, negative only indicating the direction. So basically, even though for the number, okay, -10, -5, 0, it's kind of increase, but the velocity it's decreasing. Like we are moving slower and slower. Yeah, number wise, it increased. But if you are, let me call that speed. Okay, but speed wise, it's decreasing. So the VT graph is going to be starting from somewhere very negative and then go straight up. And just like I said, if you still look at the change of V divided by T, what do you have? I think you would have a positive acceleration, right? Let's say this is V final and this is V initial. So you have a less negative number minus a more negative number, which turns to be positive. So actually you end up with a positive acceleration. Let me just give you like a statement and you can tell me like true or false. So if I say positive acceleration always indicate speeding up, it's a false. Okay, this one is a false statement because we just see the case where A is positive, moving at negative direction, slowing down, right? Not always speeding up. Okay, so that's that. And then the last one, so let's quickly finish the last one. First of all, let's see this time, the slope increases. In other words, it become more negative, right? It become more negative. So more negative actually indicates speeding up. Okay, it actually indicates speed up in negative direction. In a negative direction. So therefore, our curve is gonna like this. And then the last one, you can still take this as the final velocity. This is initial. Final more negative minus less negative. Still give you negative. Okay, so acceleration is negative. Okay, so this is the case where we are walking backward, speeding up. So let me just write down here. Speed up at negative direction, have a negative acceleration. And then that's it. So that's the whole story.